Myself, Dr. R. Good morning to all. Myself, Dr. R. Mohandas, HOD of ECE Department, Balaji Institute of Technology and Science, Warangal. I am grateful to our Chairman Sir, Principal Sir and AO Sir for the extensive support to conduct the webinar. I thank Radha Krishna and his team and faculty member of ECE Department for coordinating this webinar. I am grateful to the Pantech solution for accepting the invitation. Finally, I thank all the participants. Thank you very much.
Hello guys, we all get the greetings from the HOD of Balaji Institute of Tech and Science, Warangal. So, good morning everyone. So, good morning. So I warmly welcome you for this session, Face Recognition Using Deep Learning, which was organized by Pantech Solutions and Balaji Institute of Tech and Science, Warangal. Good morning guys, good morning everyone. So before going on to the session, I want to make sure whether is it audible guys? Is it audible? Please tell me yes or no. So is it audible guys? Yeah, good morning sir, good morning ma'am, good morning students. Hi, good morning, hi. Is it audible guys? Please tell me yes or no. Is it audible? Hi, good morning. Is it audible guys? Good morning guys, good morning. Yeah, is it audible? Please tell me yes or no. Is it audible? I'm waiting for your reply guys. Yeah, yes or no. Hi. Yeah, Sasika. Yeah, thank you. Yeah, good. So we'll going on to the session guys. So before going on to the session, there is a little announcement. So which attendance link which will be given in the description or in the live chat after 11:10 a.m. So it will be available in live chat or it will be available in a description box in the of this session. Okay. So please wait until attendance form is released. Okay. So good morning. Yeah, thank you so much. Thank you for your responses. Good morning. So before we'll going on to the session. So first we'll discuss about BITS. So about BITS was established by Maheshwara Educational Society in 2001. And they are having vision to be a center of excellence in preparing the graduate professionality committed, intellectually, adept and ethical, balanced with high standards by imparting quality education with international standards to excel in their career, to meet the challenge of the modern world and adapt to the technologically changing environment. So if we discuss about a Pantech, so it was founded in 2004 and we are almost having 7 branches. And we have 100 plus teams and we have conducted 1500 plus workshops and 250 plus faculty development program and 100 plus seminars. And we are having a research and development center in Chennai, and we are the manufacturer of lab equipment such as 8051 or 8086 or other microcontroller and microprocessor boards, as well as FPGA and artificial intelligence, and as well as sensor as well as modules. As well as we are the manufacturer of lab equipments for electrical departments such as fuel cell and renewable energy lab equipments and brain computer interface technology, and we are almost handling a lot of technologies regarding engineering, which includes artificial intelligence. We are providing industry based solutions for artificial intelligence as well as face recognition and face detection. And we'll move on to the application of face recognition as well as application of deep learning, which includes current and future technology or future application. And finally, we'll have a live demo on face recognition using deep learning. Okay. So this up to agenda. So we are in the start of the session. I hope you are getting good audio, right? So first we'll discuss about overview on artificial intelligence. So what do you mean by artificial intelligence? So artificial intelligence is nothing but a machine which is trying to or which is going to demonstrated by having the intelligence as like a humans. So for example, if you take a small baby, or if you take small baby, okay, so newborn baby, okay, will it know what is object, what is person, what is man, what is woman, what is purse or what is camera, because that newborn baby doesn't know about anything, right? So what we'll do, we will do the learning for the baby. So we will show mobile phone. So this is the mobile phone. So take the mobile phone, pick up the mobile phone, drop the mobile phone. So likewise, we'll teach one by one, right? So we'll teach the baby to learn itself. So it will automatically, it will see a wide variety of mobile phone models, and it will identify the mobile phone. This is the mobile phone. Okay. So for example, if you take you, okay, if your age is about 28 or 20, 23, 25 or 28, okay. So for 25 years, you have seen lot of mobile models, like includes Nokia 110 or Samsung or previous touchscreen mobile, and now it is infinite display. So lot of mobile you have seen. So you have knowledge on how the mobile phone looks like, right? So you have those kind of knowledges. So by feeding those knowledge to a machine to have those kind of intelligence, those are known as the kind of artificial intelligence. Okay, artificial intelligence, the intelligence is given by the feeding, is given by feeding the experience of human to the machine in the format of data. So for baby, what is kind of data? So baby will see, baby will look around everything through his eyes, and the baby will listen for voice based learning, and the baby will smell or sense for sense based learning. So baby will learn from every sensory organs, right? So instead of that, for robots, we will put up sensors or mics or speakers or cameras for doing every human kind of same kind of sensing activities. Okay, for visualizing kind of recognition, we'll put up a camera. For sensory based activities, we'll put up a sensors. And for recognizing, we will put a mic and speakers, as well as some kind of software intelligence. Okay, so first thing, our machine, we need it will acquire those kind of intelligence in the form of data. Okay, so for baby, we will do the teachings, right? So this is the water bottle, this is the mobile phone, this is the wallet. So likewise, we will do the learning, right? So instead of that, for machines, we will give those kind of learning in the format of datas. Okay, so here we require a bunch of datas. Okay, so we are going to feed some kind of data in the form of experience to make machine to be intelligence. Okay, so we'll move on to the deep learning directly. Actually, artificial intelligence is the biggest circle. So inside that circle, the first inter circle is machine learning, and in depth we'll have a deep learning. Okay, so this is the function. Actually, if this deep learning, so this deep learning is inspired by the human brain. Okay, how human brain is doing, or how human brain is performing. Okay, how the human brain is performing. So for every reaction, your brain nerves or your brain neurons will activate similar functions. For example, if you touch a fire, okay, if you touch a fire, suddenly that particular neuron will be triggered, and it will initiate you to take off your hand. Okay, so those kind of neuron activities, some kind of activation function is happening in your brain to activate or some kind of reactions. So for example, if you take some kind of recognition part, okay, now I am going to show one water bottle. Okay, so now I am going to show a water bottle. So from your childhood itself, you have already seen lot models of water bottles. So with cap or without cap, or small one or large one, different colors, shapes. So lot of water bottles you have seen up to your age. Okay, so those data or those images within single day machine can't learn, right? So that's why what we are going to do is, we are going to collect a data set of water bottle, or we are going to collect image of water bottle, up to 1 lakh images of water bottle, different models and different structures and different colors, wide variety of water bottle we are going to provide. Okay, water bottle image. Okay, so that is nothing but image of that is the form of data set. Okay, so data set. So here, so if you see the brain structure first. Okay, so first there is a vision. Okay, you will see it. Okay, you will see from your eye, right? So from your eyes, your brain will process it. Okay, so if someone says this is a water bottle, okay, so you will say, you will identify it's okay, this is the water bottle. If this is the water bottle, it will look like this. So you will identify the pattern or structure from your brain. Okay, and after 10 days or 20 days, if I have shown same kind of structure to you, you will recognize that is a water bottle. Why? How? Because you have already seen and you have already identified the pattern of the water bottle, right? So vision as well as brain and then recognition are same as like in the deep learning. So it was told that, so first input will be given as data set, and then we will do the training for complete data set, and we will result as a model. Okay, and will result as a model and will result or will give us a recognition. So in the recognition, it will do the like kind of to identify the image. Okay, to identify the image, what the image or what the object is present there. Okay, so that kind of identification, it will be happened in the deep learning structure. So first we are going to provide the data set, and brain or neurons or any deep learning model gonna train it to result to you a model, and finally it will do the recognition. Okay, so first so main advantage or here main disadvantage is, here we need to proceed bunch and lot of tens of data. Okay, so only thing is required is more number of data. So that's the main thing which we required in deep learning. Okay, so there are a lot of questions. So why deep learning? So why we are using a deep learning? Why instead of using normal image processing application, why we are using a deep learning? Okay, I'll answer you now for that. Okay, for example, if you are going to deploy some kind of deep learning application, some kind of recognition application to recognize apple or banana. Okay, can you tell me what is the future, common future, or what is the different future which is in the apple and the banana? Can you tell me? Yeah, it is already there. If you see apple, it is red color. So it is difference in, there is a difference in shape, right? So apple is in like spherical or banana is in different structure. Okay, so if you see other differences, color, right? So that is apples, in apples they are there are green, red, and pale normal orangish color. So those kind of colors are there. But if you take banana, so it is in yellow, green, or red. So that kind of difference are there, right? So we have a lot of difference between apple and the banana. So and here I just want to say only a difference. Okay, and just for an example I'm saying. Okay, so apple and then banana. Okay, so if you are deploying any normal computer vision application, what you have to do is we have to write the code, or we have to write the algorithm for future. So we have to specify the future in our algorithm itself. For example, if you are going to deploy one apple and the banana classification. Okay, let us assume, take apple and the banana classification. You have a number of apples in your hand and bananas in your hand. Okay, now you need to classify some kind of image, normal common image processing application to classify this is the apple and this is the banana. On that, if you are taking that normal image processing application, you have to write the algorithm by specifying its features. So for example, you need to specify its color. So these are the color possibilities of the apple, these are the color possibility of the banana, these are the shape future of the apple, these are the shape future of the banana. So like that you have to specify the future. The main advantage of the deep learning is it will automatically identify the future of the input data which you are given by analyzing every images of two labels. So the labels is nothing but one is apple and another one is banana. So by analyzing every futures automatically and to give a prediction, so it is an apple or it is an banana. Okay, so this is kind of automatic future extraction. Even though if you take machine learning, so on machine learning also it will also use the same. So same in the sense we need to specify the future. What is the future? What is the future of object which we gonna classify? Okay, if you want to classify man and the woman, okay, so you will place the hairstyles or costumes by using the futures. You will recognize that is a man and this is a woman. So from that we need to specify the future. The main advantage of deep learning is automatic future extraction. Okay, so that's the main keyword. Okay, you just remember. Okay, so automatic future extraction. Okay, and then in the deep learning there are further challenges also there. So for example, what the challenge is, so if you see here, for image, for example, only I have used only 3, but so for example, let us assume, okay, so same as like take you as an example, okay, for up to based on your age, you are 26 years old. From the 26 for up to 26 years, you have seen lot and lot variety of apples, like a half cutted apple or 4 half apples, bananas, lot variety of bananas and half cutted bananas. So we have seen for 26 or based on your age, you have seen lot of image from your eyes. So you have seen lot of images of apple as well as a banana. Okay, so you have that 26 years of knowledge based on your age, right? So if your age is 26, so for 26 years you have seen lot of images, like it may have crores and crores of images you have seen about apple. You have seen real apple in different angles, half cutted and fully cutted. So lot of we have seen lot of images up to your age, right? So now I'm going to create one newborn baby, that is artificial intelligence, normal one, a new machine which should recognize an apple and banana. Within short time, how can I give those kind of visual? I can't put up camera and I can't show every images of street markets and my home dining table, fruit baskets. So I can't show like that, right? So what we can do is, there are a lot of data set which is data set providing websites are available, like example Kaggle. So a lot of sites are providing data sets. So they will give 1 lakh images of apple with different shapes and color and half cutted, fully cutted, 4 piece cutted. So likewise, they will provide millions and millions of images of apple alone and as well as for banana alone. So what we can do is we can do the training for billions and billions of images. Okay, so we will do, so first thing we require more number of data. So we require more number of data for that. Okay, so that's the thing. So for more number of data, we need a better computer, right? So we require a computer. So for example, if you are using a normal PC, so central processing unit, so which was organized by less bandwidth and it is latency optimized and not suitable for real-time application, where performance is the main factor. For example, if you are deploying normal any different recognition, any person or object recognition or any in-depth face recognition, okay. So but if your PC is only central CPU, normal CPU, so if you want to train for a lot of images, so for example, now you have to deploy one face recognition application in your college entrance. Okay, so you may have 1 lakh students, 1 lakhs, right? So 1 lakh, you just remember 1 lakh students. Okay, so for each student we need to provide at least 500 images, 500 face images. Okay, so for 1 lakh images we need to deploy 1 lakh into 1 lakh multiples of 500 images, right? So we need to provide lot of data. Okay, so now I am going to do a training. Okay, but now training requires a computational power. So your computer should have that kind of computational power to train it. Otherwise it will get down, it will slow down, or it will be frozen. So a lot of issues will be happened in the CPU, normal CPU. Okay, so that's why we are moving on to the GPU, that is graphical processing unit. You have already heard about the GPU, right? So there are graphical processing unit are there. So graphical processing unit, for example, NVIDIA, you have heard about NVIDIA, AMD. So who are all gamers, they will use the graphic cards to accelerate their PC to handle those kind of high graphics games. So same as like for this deep learning or for this artificial intelligence also, we require that kind of graphical processing, that is GPU, for to do the training, because it is it has high bandwidth and it is a thread parallelism and easily programmable registers, and also it was optimized with the on the basis of bandwidth. Okay, so that's a bandwidth optimized. Okay, so that GPU will be helpful for have high processing, which has high computational power. For example, let us assume take same as like 1 lakh students, so each of 500 images. Okay, 1 lakh students of 500 images, we have to train it. Okay, for those kind of training, so if you are done the same training in CPU, it may take up to 2 months or 3 months. So since it has very less computational power, it only it will take more number of time to train it. So it may take 2 or 3 days or 4 days or 5 days, even based on the data set it may take up to 4 months or 5 months also. So based on the data set, that normal CPU will take more time. Okay, instead if you are going to GPU, graphical processing unit, it may train within 1 hour. It may take very less number of time to train more number of data sets. So that's why we are moving on to the graphical processing unit for artificial intelligence based applications. Okay, so that's why that's the difference between CPU and graphical processing unit. As well as while real-time deploy, so for example, if you take old mobile phone Nokia 010, okay, so you will turn on the video camera. Okay, you will turn on the video camera and you just drag, or you just move the camera. There you can see the buffering, right? So first it will in the first frame, and later on only it will show the final frame. So there are a lot of delay will be there, right? So those kind of delay will be also be there. So if you take graphical processing unit, if you take highly accelerated or high computational power your mobile phone now, so that mobile phone have that kind of optimization. You have a very clear video processing rate, so it doesn't has any lag or any latency. Okay, so that's the main advantage of hardware acceleration. So that's why we can move for graphical processing unit. Okay, on the graphical processing unit, so first we'll see deep learning libraries. So what are the libraries are there? So there are, so for example, if you take, so these things, no, so we can use Python as well as C++. Okay, so on the deep learning, there are plenty of deep learning libraries or normal Python libraries. Everything is gonna happen in libraries. So on the libraries, I have just shortlisted very few libraries for you. Okay, so if you take a TensorFlow, so that is a very commonly used deep learning library. So like it will use numerical computation using data flow graphs, and it will run as a backend for the Keras. So first we'll discuss about the Keras. So Keras means it is a framework of deep learning. And main advantage is the same code which you can run in a CPU as well as a GPU. So for example, if you have a normal CPU or laptop, as well as you are having Jetson boards, so NVIDIA's Jetson Nano or NVIDIA's Jetson Tegra, that is kind of GPU development boards. So if you have two environment, so if you have those kind of things, same code you can deploy it in CPU as well as GPU. So which is developed by using a Keras. So that is main advantage, and using TensorFlow as a backend, and mainly for convolutional neural network, and it doesn't support multiple GPU. So multiple GPU for more hardware acceleration. Okay, so you can interface 2 GPU at a time to have more number of processing. Okay, so if you take TensorFlow, it uses a numerical computation using data flow graphs, and it also runs as a backend for the Keras, and distributed computing on multiple GPU. This TensorFlow is provided by the Google. So this TensorFlow will support multiple GPUs. So we'll put up 2 NVIDIA Jetson. So it will run those single program parallelly, so that it will be very fast when compared to running in a single GPU. Okay, and then if you take up Torch, so that is a old machine learning and deep learning library which also supports a CUDA for parallel computation, and also it has supervised the image problem with the convolutional neural network. And if you take Cafe, so it has very high performance, and it will have option to tuning hyperparameters, and this was developed for CNN and RNN by the Facebook, and also it also supports CPU as well as GPU. Okay, and if you take MXNet, is also very popular, which uses more number of language bindings are there, since you can use Python as well as C++, and it also has distributed computing. So and NumPy and SciPy, it is very basic library for doing any scientific operations or any array kind of operation, reshaping, index, reshape or resize or matrix kind of operation. You can use NumPy as well as SciPy. So these are a lot of libraries which you'll use. If you take machine learning, there are also a lot of libraries like linear regression or logistic regression or SVM. So a lot of libraries are there. So we are going to here in this demo, we are going to use machine learning as well as a deep learning. I'll tell you why we are using those kind of things. Okay. So these kind of libraries are there. So further, there are a lot of libraries. This single session is not enough for detailing the deep learning. Okay. So we will have a separate 3-hour session for that. So I already told you this deep learning is inspired from the main real brain neuron. Okay. So if you see this brain neuron part, so it has dendrites, so it has cell body as well as axon and synapse. Okay. So these are the structure of the neuron. Okay. So this deep learning is inspired by the neurons. Okay. So if you see here, this is the neuron. Okay. So intermediate, so it has dendrite. From the dendrite, it has cell body, so which acts as activation function to activate any kind of functionalities. So these are the structure of neuron, real neuron in our brain. Okay. So in the below second figure, which shows the deep learning structure. So input, we have this kind of dendrites, and as an activation function we have before that we'll have neurons, and we'll have activation function, and finally we'll have output. Okay. So input is nothing but a data. So in the data you can obtain from the camera, or in the data you can hear from the mic or mic. Okay, your microphone or sensors data. So these are the inputs, and neurons, it will process it, and activate function will activate the respective output, and the output in the sense speakers or output response in the display. So those will be happen in the output. Okay. So and then activation function. So in the activation function, there are a lot of activation functions are there. So for example, step function, sigmoid, tanh, ReLU function. So this function we have already discussed in the previous session, which is conducted in the deep learning. Okay. So you can refer after the session completed. Okay. So mainly I will use a convolutional neural network. So if you have understand the convolutional neural network, it will be very helpful to have in-depth using libraries of Keras. So it will Keras uses a convolutional neural network. It is very easy to use. So if you take CNN, it will learn the future, or it will identify the future automatically. Okay. And also it will capture, it is also capturing the spatial features where artificial neural network cannot. Okay. And also it will also it also follows parameter sharing like RNN. It applies single filter in different part of a single image, whereas artificial neural network can't do. Okay. And then it doesn't have a recurrent connection like neural network. Instead it has convolutional type of hidden layers. So I'll show the structure later. And then it already have convolutional and pooling functions are used as an activation function. So from the figure you can able to identify. So if you take convolutional kind of functions, so input image and other as a filter. So if you take one single image, I'll take that is the input image, as well as I'll apply some filter in the same image part, and I'll take as a filtered, that is kernel, and will produce the output. So that is known as a convolution. So if you take a pooling, so picking up the maximum value from the selected region, that is a maximum pooling, and if you are picking up a minimum value of a selected region, that is a minimum pooling. Okay, these I've already discussed detailedly in the previous session. Right. So if you take this normal convolutional neural network architecture, so we have already seen normal neural network. So neurons is nothing but it is completely gonna be interconnected. So interconnected, in the interconnected, so in the interconnection, so first we'll provide the input. So this is this to represent this input data is nothing but input data. And intermediate, there are a lot of layers that are all the hidden layers. Okay. And finally we'll have an activation function, and very final state, we have the output functions. Okay. So for example, for to know the architecture, how this deep neural network is doing those things. So DNN, so that deep neural network is nothing but which the network or which the layers has which the network has more number of hidden layers. So those are known as deep neural networks. Okay. So that's why here. So here this input 28 cross 28. So which resembles the height and width of an image. So it will be passed to the convolutional first layer of the convolutional, and then it will move on to the max pooling, and it will feed to the convolutional 2, that is a second convolutional layer, and then it will feed to the max pooling layer, and then it will pass to the fully connected layer for activation function to activate which neuron is the right neuron. So for example, here we have performed the character recognition. Okay. So here we have performed the character recognition. So in the character here it represents as a 2. Okay. So on the final output layer there are up to have 10 neurons. Why 10 neurons? Because the numerical. So its number start from 0 to 9. So 0 to 9 it will be finished, right? So 0 to 9. So I am going to classify the number from 0 to 9. Okay. So that's why in the final layer, that is fully connected final layer, we will have up to 10 neurons. So only 10 neurons for representing each other every numbers. Okay. So what I am going to do is, so here we have used number 2. So while crossing over the every hidden layers, it will extract or it will identify the future. So for example, if you take this 2, there are some curve part is there, right? So there is some kind of curve part. So if you take 1, there will be no curve part. So the future is here, there is some curve in it. So by passing over towards every future or every hidden layers, it will identify the future of the current image. Okay. At the final stage, the activation function will activate the accurate or perfect layer, perfect neuron. So here the 2 is the result, 2 is the answer. If it is trained properly, if it has more accuracy as well as very less loss, so it will accurately activate the only the second neuron, that is third neuron, that is number 2. So from that we can able to identify the given handwritten image was 2. Okay. So that's the thing. So intermediate, so that will be an input layer, and finally we will have output layer. In intermediate we have a lot of connector layers. If the number of hidden layer is very larger, that is known as a DNN, that is deep neural network. Okay. So this is the process. Okay. So how the layers will pass over. Okay. And then face detection and the face recognition. Okay, if you take if you are starting from the face recognition, what is the initial part? So the initial part is we need to identify the face. So if you take this image here, so this it has a face, right? So from the complete frame, so first we need to detect the face. So face in the sense only the eyes, nose, and then mouth. Okay, only this part. Okay. So first need to take the image, detect the face, and then how the face is differentiated from one another. The face is differentiated by using or the help of the facial landmarks. So landmarks is nothing but there are a lot of landmarks, 68 landmarks are there. So landmarks are there are 68 okay, every parts will be identified. Okay, every parts will be identified. So every parts will be identified by having coordinates, by identifying the coordinates. Okay, so on the coordinates, so we will monitor or we will locate the facial parts. Okay, from there we will compare or we will compare those kind of landmarks with the other person to identify this is the person, this is that person, this is that person. Okay, we will identify it by using that facial landmarks. Okay, so sorry for that buffering, it has happened towards internet. Here internet is not constant, So I hope you are getting this audio now, right? So while buffering, I didn't speak anything. Okay, I'm starting it from the first itself. Okay, so first thing, the phase. First part is the phase detection. On that phase, after detecting the phase, we are going to place 68 landmarks in the phase, so that it will detect or it will locate every coordinates of eyes, nose, mouth, and after that we will compare the same location coordinates of the face to the another person to identify this is the person, this is the another person. So this is Sanjay and this is Praveen. Like that we can able to do the recognition by using the landmark coordinates. Okay, so that's the thing we are going to see in the demo. Okay, so we'll share now. So first we'll discuss about application of deep learning and face recognition. So on the face recognition as well as deep learning, there are AI doctor. So I hope I think a lot of now this coronavirus, it's going very intense everywhere, right? So for example, we can deploy one artificial intelligence based doctor, which our company is already working on that project. So that project is nothing but will deploy one robot in every entrance of the hospitals. Okay, so whenever the human enters, so by triggering on the camera, first will detect the face, or will detect the person, and after detecting the person, first it will ask for the name, so to enter the name. So after entering the name, it will ask or it will identify the temperature by using a thermal camera, whether it is having more high temperature, as well as it will ask the any symptoms or what is the thing it is doing for a patient, like any cough is there or any breathing problems or any cold. So a lot of questions the system will ask automatically. So based on the user answering, so it will take on the records and it will fix an appointment for this person. This is the appointment, so it will move on the appointment to the doctors. So while he is returning back to the same system or same hospital again, so it will identify the face automatically and automatically give you the welcome note. Hi Sanjay, so appointment is fixed now, so you can consult the doctor now. So these are the medical or these are the medicines you have to take, these are the prescription. So lot of answers which can be directly given by the AI system itself. So instead of having close contact with the doctors, so since these doctors are very valuable, so we require these kind of artificial intelligence based application for detection or recognition. So this AI doctor which also uses the face recognition part. In the face recognition, first it should detect the person and it should detect the face and it should detect the face recognition to identify the specific patients. So either Sanjay, so if it is Sanjay, it will have a records like so if it is Sanjay, it has records like he's having he is normal, so he doesn't have any fever, he is very good. It is kind of this is the cold which has happened through the only climatic change. It is there is no temperature change, sorry, there is no high temperature. So like that we can maintain the records by in the system itself. We doesn't require any kind of doctor to have a close contact with the patient. To avoid, this is the main application which we can use. And the prediction of disease for medical image. For this application also we can take example as a medical image example as this coronavirus. So we already done one project called COVID-19 detection by using a medical image. So from the medical image we going to deploy to detect the COVID-19 presence or absence. So it also used for diabetic retinopathy. So diabetic retinopathy is nothing but kind of blood leakage in our eye walls. So by using a medical image we can do those kind of prediction in the medical image also. Okay, so those kind of process we can do by using a medical image with the help of deep learning. Okay, and then fruit and vegetable classification. For cultivation, fruits and vegetables need to be segregated. So if you are using more manpower, we need to classify more number of fruits. Is it a rotten or is it a well good or is it damaged, or a lot of classification we need to do. So by using a deep learning algorithm, it is very easy to use as well as very easy to handle, as well as it also reduces the human efforts. And also why we are using artificial intelligence more is, if you take human being can't work for 24/7, but if you take any artificial intelligence, it can do. Okay, so that's why we are moving on to the artificial intelligence. Okay, and then surveillance system, these are the very biggest and very requirement applications which is already there. So in the surveillance system, the first thing we'll discuss about the drones. So first thing we'll discuss about the drones. So if we take a drones means it should detect a vulnerability. So vulnerability in the sense, we can deploy AI based camera in the drones, so it will detect a person automatically, and if the person is behaving some illegal activities, we can monitor through drones and we can send a cop directly there, or we can send our alert, or any murder gonna happen means if someone is holding a knife, so we will, by using object recognition, we will detect a person as with a knife. So that is very hazardous, so it will trigger any sound, police siren, or it will give alert to the cops to avoid those kind of deaths. So a lot of things we can monitor from the drones itself. So from the drones we have to monitor the face for recognition, either he is a criminal, either he is a normal person, normal citizen, so that we can monitor using a drones. As well as instead of keeping in a drone, there are a lot of traffic cameras already there. So nowadays, what is the current scenario? So if any vulnerability happened, after that only they will use for surveillance camera. So some of the criminal activities are avoided since there are cameras. So we need to avoid that. Why not avoid that doing in front of the camera, and not to avoid that completely. They'll do the same thing where the camera is not implemented, right? So after everything happened, nowadays these cameras are only helpful after everything happened. This camera is really helpful, will be helpful to capture that culprit, right? So by to avoid that, we'll put up a artificial intelligence or this deep learning based cameras, sorry, normal cameras with this deep learning application to detect the person while he is trying to do something. Before itself we will give a alert. Okay, so those kind of activities we will deploy in traffic cameras. So any accidents or any kind of any vulnerability, so those can be monitored by using the traffic cameras as well as a drone. So nowadays cameras are simply normal cameras. So instead of that, our idea is to deploy any deep learning application in the camera to have a alert as well as to avoid those kind of actions. Okay, so that is the main application of surveillance system. So autonomous vehicle. So I hope you are all know about Tesla. So Tesla, the electric vehicle which also uses autonomous. There are a lot of industries are moving towards autonomous to make human to be very free. So every car or every industries are turning into autonomous. So by using a camera, there are a lot of parameter if you take this autonomous vehicle part. So if you take autonomous vehicle part, the applications such as pedestrian detection, lane following, lane detection, parked vehicle detection or moving vehicle detection, traffic sign detection, stop sign detection, or traffic signal detection. So lot of parameter which is based on the cameras. So by using this deep learning we can use that. So even though there are more advantages, like if someone is crossing the road while we are traveling in the car, by using the camera with the face recognition or face detection technology, we will detect the face, and we can also identify whether he seen us or not. Is he noticed us or not, noticed our path or not. So that also we can able to do the recognize by using that one. So if you see here, I have already collected images of data sets of a lot of peoples here. So and also I have collected unknown also. Why? Because if you are going to do some kind of face recognition application, so other than any person, it should know unknown. So we have put up loaded some kind of images in unknown also. Okay, I've collected lot of people's images. Up to we almost have 100 images per class. Okay, so we have seen this. So we have seen this 100 images. So for every classes I have loaded up 100 images. Okay, now I'm going to show the demo. So I have already trained it. So I have already interfaced one USB camera here. Okay, so to have this face recognition. So we have passed a lot of models. I'll tell you what are those. First I'll see the demo. Since those data sets were created before 1 year, so that's why it's doing this classification. So here it shows Rajan for up to 70 or 87% of me. So it also uses multiple face detection also. So if you see here, there are a lot of lag is also there, right? So if you are deploying this deploying this in like GPU, like NVIDIA Jetson or NVIDIA Jetson Nano, it will be very accurate, or it will also be have very high frame rate. Okay, now it only uses 2.55 FPS. Okay, now I'll tell you. So okay, so first thing actually what we did was, so first thing which we require is face detection. Okay, so first we require is face detection. So first we'll detect the face, and then what we'll do the face recognition. So that's the first thing. First we should detect the face in my camera feed, and then it will do the face recognition part. Okay, so what we did was, so for face detection we have used a deep learning model. Okay, so for face detection we have used a face deep learning model. So here it represents deploy prototypes as well as a REST 10 with a cafe model. So there are a lot of model, guys. So PyTorch or cafe or so there are Keras models. So there are a lot of model format also there. Okay, so here we have used a cafe. So to have here we already have this model to detect the face. Okay, and then second further we'll do the machine learning for creating or to compare with the other images. Okay, so there are some kind of embeddings also there. So embeddings is nothing but, if you see this data set, what you'll understand. So if you see this image, okay, so if you see this image, there are complete image, right? So complete frame is there, but this is not the required thing which we require to compare with the compare for face recognition. So instead that what we need to do, we need only a face part. Okay, that I'll show you. So if you see here, there is a difference between that image and this image. So if you see this image, only the face part is cropped out. So that is known as embeddings. So we require only a face part to do a face recognition. If we are doing with the complete frame, it won't get that much accuracy. It is not the proper way to do a face recognition. So for face recognition, from the data set which are captured, we need to do the embeddings to crop out only a face image. Okay, only the face part. So after getting the face part, we will load the 68 landmark in the face, so that we will perform the face recognition, face recognition. Okay, so that's the thing, the difference between the normal data sets and the embeddings. So first we'll take the data set as per the complete frame in the based on the camera size, and then we'll move on to the face embeddings to crop out only a face image. And after that we'll compare by using the machine learning SVM to do a face comparison part, to choose this is the user, this is the Sanjay, this is unknown, and this is that person. So like that we need to classify that. So this can be further modified or further improved by using data sets by creating the roll number. So if a lot of people are working in colleges, so if they need to deploy one smart attendance system automatically, so they'll place up the camera. Okay, so they'll place up the camera. So if you need more accuracy, you need to provide more number of data. So here I have used only 100 images, since I have used only classes of up to 5 to 6 users. Okay, instead if you need to use more number of persons, so we need to use more number of images per student. Okay, here I have used 100 images for me, 100 images for every person. So instead, if you need more number of images, we need to provide more number of images to have a better classifications. Okay, so this is like creating a data sets or database for to presenting or to have roll numbers. So in time and out time, this is the roll number and this is the person. So here in this date he is present. So instead of making it manually, we can go for this camera based deployment for face recognition. So in the face recognition, I'll give the quick overview. So face recognition, first we'll do the face detection part. So for the face detection, in this application we have used a deep learning model, DNM, for detecting the face. And after that we have done the embeddings. So embeddings nothing but cropping out the face part. And third, we'll using the SVM machine learning for doing a face recognition. Okay, so for here example, here we have passed the argument for embedding model. So this is the embedding model, and in the recognizer, so we have already trained in the format and we have said in the format of pickle. So pickle is also one on a format of resulting model. So here we have imported a lot of libraries, that immutals for taking the camera from the frame video stream, and then these are the argument, that is argparse, which is required. So first thing we need to pass as an argument for one is for object detection, we need to pass that face detection model, and then for for face recognition we need to pass that machine learning trained model. Okay, so those things we have passed as an argument, and after that argument we need to classify or inside that while true. Before that we have initialized already the cameras, and we have loaded the recognizer, and LE nothing but label encoder. So label here, label is nothing but Sanjay, Lokesh, Rajan. So a lot of names are there, no? So those are the label encoders. So label for identifying the who the person is. And inside the while loop I have initialized the camera. I will read the frame of the camera, and after that we have initialized the immutals, and we have resized the image, and then we are constructing one blob from the image to have a further classification part, and we have visualized the detector and the detection of so from the input image blob we are initializing or we are getting the values of detector, and we are convert into the detection part, so to have a detection area. So after identifying that one, we need to draw a boundary box. So boundary box around the face. So for that, we'll identify the start x and start y and end index and end y to form or to draw a rectangle over your face for the detector region of your face. Okay, after the face blob, we are passing the recognizer. So on the recognizer, we have to identify the preds. So preds is nothing but one kind of array. Okay, on that array, based on the number of name embeddings, it will give you the name like Sanjay, Rajan, Lokesh, Sharavan, like that. It will give a name. So on the name, on the which person it's having more accuracy. So it will give that percentage of accuracy in that array. So from that array, we'll identify the name. So what the name of the person is, and after that, we'll plot the rectangle as well as we will plot the accuracy percentage as well as their name in the frame which is obtained in the output video. Okay, so these are the things. So that's up to now. So after finishing everything, we are going to close every windows as well as we are stopping the camera frame. Okay, so these are the another code, and these also uses another kind of face recognition. It uses a hair cascade frontal facial algorithm. So it is popular. It is very popular. This is trained by using a machine learning. So from that also we can do the face recognition part instead of using deep learning. But only advantage of using that deep learning is there you can deploy more number of persons. There you can use more number of persons by increasing more number of data sets so that it will train automatically. But here it doesn't require, it is not any normal deep learning. So it doesn't have any training also. Okay. So that's why, but it has very less number of accuracy on classification. This by using a hair cascade. So that's why we are moving on to the deep learning for better classification as well as for more number of usage or more number of persons classifications. Okay, so that's why we are moving towards that kind of face recognition by using the deep learning. Okay, so we are almost in the question and answer session, guys. So if you have any questions, you can ask now. I'm waiting for your reply. Guys, I'm waiting for your questions. You can ask me your questions now. Sir, is this session helpful for diploma students? Nowadays, every departments, like any engineering or diplomas, not like that. So every industries are moving towards artificial intelligence, deep learning, machine learning. So this session or this concepts, it will be helpful for every person. Do I need an extra hardware to put it in my laptop? No, it is not. No hardware is required. So for basic operation, you can use your PC itself. You can install Python as well as and its libraries in your laptop to do those kind of deep learning application in your PC. Can we predict suicidal tendencies in a person using deep learning? Very good question, sir. Can we predict that suicidal tendencies? So it is a very good question, right? Yeah, why? Because this is the main concept we have to speak it for. Suicidal tendencies. So that suicidal tendencies, so there are a lot of things. One, if you are using any camera based thing, if they shown by, if they're from the face activities, if we can able to modify, sorry, if we can able to monitor, or if we can able to identify from their face itself, we can do it in the same deep learning. If we can't able to identify from our eyes, it can't be done in the deep learning. Okay, so if you want to do that kind of suicidal kind of predictions or detection, so we require a large number of data sets. So for data sets, for up to 1 week, we'll monitor the face of every person to identify either he is in a positive or mood state. We can't identify that in a mood state. So for that kind of, we can go for any brain computer interface technology with the artificial intelligence deployment for analyzing the brain waves to detect the mental disorders or mental disturbance for to prevent the suicidal activities. Which language should be used for deep learning? So for deep learning, you can use this Python programming as well as C++. Please, sir, can you tell us what library of Python and software do we require before we do it? So before we do it, first you'll practice on the keras. For face kind of application, you especially require dlib also. So dlib, keras, and basic libraries such as numpy, scipy, mutrils, opencv. So there are a lot of libraries which require. Sir, can we perform deep learning using Julia language? I'll check it and I'll update you. I'm waiting for your questions, guys. You can ask me now. Is it possible to make mask detection and face detection at the same time? Chetan, it is a good question, sir. Actually, it can be done. So for face detection, it is nothing but we'll put up a face mask. So we'll create a two kind of folders. One is with a mask and without mask. So for with the mask, we'll put up a mask and we'll keep it in a certain folder. And in the second area, we'll keep it in the second folder without mask. So we'll do the training on it. So perfectly it will work for mask detection. It's a very good question. Can deep learning identify a person wearing dummy face? Wearing dummy face means is it a mask? So that means we need to provide that kind of data sets. So listen, if you are taking a baby, okay, if you are taking a baby, so if you are teaching a baby that this is a mobile phone, okay, now I am going to teach a baby this is a mobile phone and this is a water bottle. What the baby will do? So after it learns, so it will also say this is the mobile phone and this is the water bottle, like that baby will say. So if you are teaching a baby wrongly, it will recognize wrongly. Okay, to overcome that, we need to do perfect learning based on the data set. What you give, what will you will get those same as exactly. Okay, so if you are training for face detection or duplicate face mask, so we need to provide that data set. So machine learning or deep learning will train it to identify the dummy face based on your data set. So based on the data set with more accuracy and less lot. That is the main motive. First motive, we require more and more number of data set for better accuracy. Okay, so that is the first parameter for this deep learning. And second, we require more accuracy. Okay, and then third, we require very less number of loss. Okay, so that's the three part which we require. If the multi-part phase comes, then is it possible to identify each and every person accurately? Yeah, of course. But if you need a more accuracy, if you are facing any difficulties or misclassification, you should go for providing more number of data set for every individual person. For deep learning, you can go for what common data set website freely available for deep learning. You can go for Kaggle, or else you can collect images directly also. Can deep learning be used in videos? Yeah, exactly, we can do. Why? Because here we are using already camera video, right? Instead, you can use in a local video also. How to detect a face instead of using R cascade? So that's why we have seen now. So I have shown the first demo now that it doesn't use that R cascade. So instead we have deployed deep learning for face detection and machine learning for comparing to identify the person's face. For deep learning, we have by using a deep learning trained model only we have done that face detection part. Okay, so that's the alternative of car cascade. For face recognition, what hardware we have to use? So if you have laptop, you can deploy it here directly, or if you are having a very low cost model which is recommended is Raspberry Pi, you can go for Raspberry Pi for face recognition real time application. But if you are having we are going to deploy for more number of users where your require is computational power, if your requirement is more computational power, you can go for NVIDIA's Jetson Nano. Okay, if you are taking only 4,000 or 3,000. So if you take NVIDIA's Jetson Nano, it is also very cheap. It also has a GPU in it. It also uses it costs around only 10 to 11,000. So language we have used is a Python. Sir, I need your help in completing my project density based traffic system image processing. So okay, I will surely help you. So you can mail me or you can contact pantecsolutions.net, or after this session completed, comment box will be released. There you can put up your mail and you can place your requirement. Can we able to calculate the population by using this face recognition? Yeah, it may be in the future by using a satellite persons detections. So a lot of application it may be in the future. So face detection is depend on the face or skin color. No, it is based on the face. Why? Because for face detection it uses the feature for detecting eyes, nose, mouth, so that it will identify. So by using a deep learning, the main advantage of deep learning to identify the feature automatically. So by providing the face detected part, so we have trained it and we have done resulting area to detect a face. Okay, so it is not required to do that. So thank you so much. Thank you for your every response. Thank you for watching these videos, and we have already conducted a lot of webinars. If you want to know to discuss about artificial intelligence, deep learning, brain computer interface, we have conducted a lot of webinars already. You can go through and check it out. And if you have any doubts, you can personally ping me at sanjay@pantechmail.com, or else you can go for www.pantecsolutions.net. There are already a contact numbers are there. You can ping it them directly, and there are upcoming session which is computer vision, which is using Raspberry Pi. So there are a lot of application or webinars we are going to conduct. So I hope you all enjoyed the session and hope you all got some knowledge on the session. And if you have any comments, you can comment below after the session completed. The comment box will be released. There you can give your comments below for my suggestion. Thank you for watching this video, guys. We'll see you in the next webinar. Bye. See you soon.